In a galaxy far, far away, Star Wars are fought with lasers and blasters, but all that is high-tech stuff. Prototypes on Earth are still being developed, they're expensive, and they're tricky to operate. It'll be a long time before they're perfected, but what if aliens attacked right now? We'd have to fight back with good old gunpowder weapons, which have served us well for ages. So, let's imagine what would happen if we use these weapons in Earth's orbit. What happens if you fire a gun in space? You probably already know how a firearm works, but here's a quick reminder. A firing mechanism creates a spark that ignites gunpowder. The gunpowder burns, and the expanding gases push a projectile out of the barrel. It flies where you aim it, or maybe not, depending on how good your shot is. Now, some might say that combustion is impossible in space because there's no oxygen. So, would a gun even fire? The answer is yes. Modern weapons can fire perfectly fine in a vacuum. You see, modern ammunition contains its own oxidizer, sealed right inside the cartridge with the gunpowder, so no need for atmospheric oxygen. In fact, shooting in space is actually easier in some ways than on Earth. First, the lack of an atmosphere is great for a bullet's ballistics, since you can completely ignore air resistance. Second, you wouldn't need a suppressor or ear protection, because no one will hear the shot anyway. That's right, there would be no sound. Firing a gun in zero gravity would feel pretty much the same as firing it on Earth. The only real visual difference would be the smoke. Instead of a cloud, the smoke trail would form a sphere, as all the particles spread out from the muzzle at the same speed. So, imagine you grab a rifle, pistol, or machine gun and step out of your spacecraft for a little scientific experiment. The shot thunders. Metaphorically, of course, what happens next? Many science websites will tell you the bullet will just fly off into space and wander around until the end of the universe. But in reality, it all depends on the bullet's speed. A typical pistol round has a muzzle velocity of about 370 to 460 meters per second. Intermediate and rifle cartridges can reach up to 1,000 meters per second. The record holder for a hunting round, the .220 Swift, can hit about 1,000 to 100 meters per second. Now, let's talk about cosmic velocities. Earth's first cosmic velocity, or orbital velocity, is 7,910 meters per second. That's the speed an object needs to orbit our planet without falling back down or flying off into infinity. Let's assume you and your firearm are already in orbit, traveling at that speed. The second cosmic velocity, the speed needed to escape Earth's gravity completely, is 11,000 to 100 meters per second. The difference between the two is about 3,300 meters per second. This means if you fire a bullet with a muzzle velocity lower than 3,300 meters per second, it won't escape into deep space. Instead, that projectile will just enter a new orbit around the Earth. Its apogee, the highest point of its orbit, will simply be higher than yours. The bullet will just keep endlessly rising and falling around our planet for a very, very long time. You'd probably want to share the bullet's orbital parameters with the astronauts on the ISS so they don't get a nasty surprise. Though, to be fair, they're already used to dodging space debris. But what if we use something more powerful? Even if you fired an armor-piercing round from a tank cannon, its muzzle velocity would be around 1,700 to 1,900 meters per second at best. That's a record, but still nowhere near the 3,300 meters per second needed to escape. Plus, you'd have to wait for Elon Musk to finish building Starship just to get a tank into orbit in the first place. Using a tank in space is pretty problematic. However, we could turn to something more exotic, like the experimental gas gun developed by engineers at Sandia National Laboratories. It's an 18-meter-long beast that NASA uses to simulate spacecraft collisions with debris and meteorites. This gun can fire a projectile at speeds up to 8,500 meters per second, and the absolute record is an incredible 16,000 meters per second. If you fired that, the projectile would definitely overcome Earth's gravity. It might even escape the Sun's gravity, especially if you fired it in the direction opposite to our solar system's movement through the Milky Way. Only then would the bullet finally leave us forever, never to return. For comparison, the Voyager 1 spacecraft is currently leaving our solar system at a speed of about 16,951 meters per second. Once that bullet is fired into the void, it would wander through space forever. Why? Because the universe is expanding much faster than the bullet is traveling. This means the projectile would never encounter any significant piece of matter that could slow it down. It just wouldn't have enough speed to catch up with a nebula or a star. Of course, we can't forget about recoil. Newton's third law still applies in space. The recoil will push you and your weapon in the direction opposite to the bullet's flight. But don't worry, you won't get blasted off into the endless depths of space. An average human weighs much more than a bullet, and a spacesuit for extravehicular activity can easily weigh over 100 kilograms. Even if that super-fast bullet from our experimental gun flies away at several kilometers per second, you'll only be accelerated backward by a meter or two per second. That's enough to lose your spacecraft, though, so make sure you're tethered to it before you start your experiment. Believe it or not, this has actually been tested. In 1975, the Soviet space station Salyut-3 became the first spacecraft to conduct test firings from a 14.5mm automatic cannon. The idea was to prepare for potential attacks from American space shuttles. It was the Cold War, after all. After each shot, the station had to use its orbital maneuvering thrusters to correct its position. So, as long as your spacesuit has a maneuvering unit, recoil won't stop you from maintaining a stable orbit. But the real danger isn't flying away. The real danger is shooting yourself. If you fire a bullet from a regular pistol or rifle, one that can't escape Earth's gravity, it will enter an elliptical orbit. It will complete a full revolution and come right back to the point where it started. That said, to actually hit yourself in the back, you'd need to calculate all the orbital parameters with incredible precision. Space is huge, and the chances of accidentally shooting yourself are extremely unlikely, but not impossible. Honestly, shooting yourself in orbit is just too difficult. The distances are cosmic, and aiming is impractical. It would be much easier to pull this off while standing on a high mountain on the moon. If you positioned a rifle perfectly parallel to the lunar surface and fired a bullet with a muzzle velocity of exactly 1,678 meters per second, the moon's first cosmic velocity, you'd create a tiny satellite. That satellite would then kill anyone who dared to climb that mountain. Just remember to duck and get away right after firing. Then you can declare the peak your own, and no one would dare challenge you for it. Thanks for watching. If you enjoyed this cosmic thought experiment, don't forget to like, share, and subscribe for more mind-bending science. See you next time.